Oh, hey, welcome to your Chapter 3, Lesson 6 lesson on compound inequalities. By the end of the day, you'll be able to solve and to graph inequalities containing the words and, or. Ta-da! Okay, so I said compound inequality. A compound inequality is an equality that is compounded. Isn't that so helpful? Okay. Compound means put together. So my Spanish speakers out there, compuesto, literally puesto, put, together. So compuesto, compound, put together. So you have two distinct inequalities joined, put together by either and or by or. So we find the solutions of a compound inequality by combining them. Or we find where they overlap. To me, I think that's the same theme, but there you go. Okay, so when you have and is going to be your overlap word. Whenever you see and, that's where two different inequalities are going to overlap, right? So if we had solutions like x is greater than or equal to 3 and x is less than or equal to 7, we want to find out, okay, where did these guys overlap? So first, let's find out, how would you graph x is greater than or equal to 3? Well, you have 3 and then go greater than or equal to like that. So your graph is looking like this, right? And then for x is less than or equal to 7, it starts up here and then goes down this way, less than or equal to 7. So goes like that. So and is both of those together. We're going to put them on top of each other. So we have a solid dot at positive 3, and a solid dot at 7, and it's where they both overlap together. Okay, so we've got between 3 and 7, and that's it, right? This is where they are both true at the same time. These are the numbers that are greater than 3, or greater than or equal to, 3, and less than or equal to 7. So when you see and, think overlap. We'll just make this purple. Okay, so and is all about overlap. Or, on the other hand, is going to be separate. Or is when you're just going to have to combine two distinct ones, right? So if we looked at, x is less than -2, or x is greater than or equal to 1. Well, if you have x is less than -2, that's that way. And if you have x is greater than or equal to 1, that's this guy right here. And you put them together on the same line. There's no overlap here because they don't happen at the same time. So or is a combination, not an overlap. So when you hear and, think overlap. When you hear when you hear or, think combine. Cool? Okay, so let's try it out. How would you represent all real numbers greater than -2 and less than -6? When we see this, I'm just going to make this purple from now on because you've seen how this works. So when you see this and, think overlap. So greater than 2. So we want x is greater than -2 and x is less than 6. So I'm going to find where they both go. So x is greater than 2 goes like this. Except my trick is I'm going to make it a little guy because we don't know where we're going, because and is where the overlap is, and x is greater than 6. So a little guy going like that. And then you connect between them. So you're only going to cover what makes both of these guys true. So here, all these numbers, they are greater than, oh, it's -2, just kidding. No, we can scoot this down just a little bit. Greater than -2. There we go. And they are less than 6. So they're in this in-betweeny area. So graph both and then shade what they both cover. Then here, all real numbers that are less than 0. So we have x is less than 0 or x is greater than or equal to 5. We're going to put both of those on our number line. So x is less than 0. 0 is right here. We go this way. Or x is greater than or equal to 5. Go this way. So now that we know where we're going, we can make our graphs a little bit bigger. Ta-da! That's it. That's literally all you do. Pretty straightforward, right? But what if you have to solve it first? Oh no! You need to get your variable all by itself, so let's go ahead and do that. I should have used this color. Get the variable all by itself. What's happening to our m? Well, we've got a -4, so +4 and +4 to all parts. Ooh, key idea. All sides of the inequality. So this inequality has 3 parts to it. Because here, this is m-4 is greater than or equal to -3, and m-4 is less than -1. So you need to add 4 to each of these parts, which will give us 1 less than or equal to m less than 3. So here, this is the same way as saying and, right? 1 is less than or equal to m, and m is less than 3. So now that we have those, we can graph it. So let's put, I don't know, like 0, 1, 2, 3, 4, 5, like that. And now we can graph our guy. So we got 1 is less than or equal to m, so we're going to start out here, go that way, and less than 3. So we're just going to shade this part right here. That's it. We've got it. Done. Cool, huh? Whenever you've got this as like one sentence together, that's an and guy. So you might literally see the word and, or you might see it in a sandwich. When it's in a sandwich, that means and. That's great, but when are we going to use this in real life? Well, how about your algebra course, my example? Okay. If you want to earn a B in your algebra course, your favorite class, of course, no pun intended, you must achieve an unrounded test average between 84 and 86 inclusive. That's a lot of extra words. Ooh. Unrounded means we don't round it. So we need an average between 84 and 86 inclusive. Inclusive means you can have exactly 84 and 86. So putting this together tells you, oh, it's a together. Look, and. So that tells you that you want a test average, okay, that's greater than 84, but inclusive greater than or equal to. So you can have 84, that's okay. You can also have 86, but your test score needs to be or up to 86. Now that we have these guys, because the inequality symbols are going the same way, you can combine them like that. Isn't that real cool? Real cool. You scored an 86, an 85, and an 80 on the first 3 tests of the grading period. What are possible scores you can earn on the 4th and final test to earn a B in the course? Well, we know our average needs to be somewhere between these 2 numbers. And we also know that to calculate the average, you need to take all your scores, you add them all up, and you divide by how many you have. Okay, so the average of the test scores, we know already we have 86, 85, and 80. So our average would be 86 plus 85 plus 80 plus whatever we get on the next test. How about we do X? Okay, so we'll have to write a note to ourselves. Dear self, let's let X be the possible scores you can earn on the 4th test. That. right? Okay, divided by how many scores we have? That's 4. And that's going to be our average. And that's what we said this was going to be. This was going to be our average. So let's take this guy. Let's squeeze him in there. Okay, excellent. So we know that whatever that number is going to be is going to fit in there. Oof, you guys, this is really complicated. To make our lives a little bit easier, I'm going to multiply each part of our inequality by 4 just to get rid of this divide by 4 real quick. So I'll do this times 4, this times 4, this times 4. And that will give us 336 is less than or equal to this expression, less than or equal to 344. Let's also clean this up real quick. 86 plus 85 plus 80 is 251. I'm going to write that neater. 251. So let's get rid of that real quick. Replace it with 251 plus x. And that looks a lot easier to read. And now to find out what x is, all we have to do is subtract 251 from each part of our inequality. And that gives us that 85 is less than or equal to x is less than or equal to 93. And for consistency's sake, let's keep our x blue so we can find it. So anywhere between 85 and 93 is the possible scores you can earn on the 4th and final test. There you go. Isn't that great? Ta-da! So a high B, or a B to an A minus is what you'll need. Right? Okay, well we've been doing ands, doing lots of ands. What if you have an or? If you have an or situation where you combine the two, then you just need to treat them as 2 separate inequalities and then graph them. So let's look at this guy first. We've got 3t plus 2 is less than negative 7. So to solve it, we'll subtract 2 from both sides, giving us 3t is less than negative 9. And then we divide both sides by 3. Since we're dividing by a positive number, we don't flip the sign. So t is less than negative 3. Or, remember we're keeping this or guy. I'm going to keep or like that, or. And then to solve this guy, negative 4t plus 5 is less than 1. We need to not add, but subtract 5 from both sides, giving us negative 4t is less than negative 4. Oh, hey, that's fun. And then we divide by negative 4 on both sides. Divide by negative 4 on both sides, giving us t is greater than 1. So either t is less than negative 3 or t is greater than 1. So to put this on our number line, let's put, I guess, 0 here, negative 1, negative 2, negative 3, 1, 2, 3. T is less than negative 3 goes this way, or t is greater than 1 goes that way. Hey, we have it. We graphed the solution. Okay, one more quick thing. So we've been representing solutions with inequalities. We've been representing them on number lines. Another way we can do that, so we've been describing intervals. We've been describing sets of numbers, basically ranges. Okay, so these right here is an interval. So we have been using inequalities to describe an interval. However, there's another way. You can use what's called interval notation. Interval notation requires 3 symbols. The first symbol are these guys right here. You've seen parentheses. Parentheses mean not included. Like the limit, the last number is not equal to. So it's up to, but not including. Okay. So basically, if you have like a strictly less than or a strictly greater than, then you're going to use parentheses. I'll get there. I'll show you some examples. If you see these guys right here, we call these guys brackets. And as opposed to parentheses, brackets mean including, like up to, like, and including these guys. When I say including, remember that they can be equal to because they have equal signs in them. So when you see symbols like less than or equal to, or greater than or equal to, use brackets because they have little equal signs in them. Okay, so you have parentheses, you have brackets, and then you also have, this one is so hard to draw. Ooh, that was actually pretty good. Normally mine are super lopsided. This is the infinity symbol. Infinity means it goes on forever. Okay, so I'm just going to show you some examples of what these guys mean. Okay, so the graph of -4, the interval of -4 to 6, means that we're going to shade in between -4 and 6. So if 0 is here, I don't have enough numbers, so we'll have these be like 2, 4, 6, and -2, -4, -6. Okay, so here we've got a bracket. Bracket means equals, so that's going to be solid. And here we've got parentheses. Parentheses means not including, so that's going to be open. So to include all the numbers in this interval, we shade the area between -4, including 4, and up to 6, but not including 6. Because this is the same thing as if you have, x, that's x is between 4 and 6, and we use a less than or equal to sign because we have brackets. Oh, hey, how do you write it in inequality? I did that right there. Yay, good job, me. That was so good. Okay, now we're going the other way. Here we have the graph of x is less than or equal to -1, or, x is greater than 2. So to write that in interval notation, that means we're including -1. So, less than. Actually, let's graph it first, and then you can see it. Okay, so x is less than or equal to -1. Oh, we need to put some numbers on our number line real quick. So we have 0, -1, -2, 0, 1, 2. Yay, right there. Okay, cool. Now, x is less than or equal to -1, because this is a solid guy going down. Oh, literally forever that way. Okay, cool. And then x is greater than 2, open, going that way. Super duper. Now let's write this in interval notation. This means that wherever x is up to and including -1 and all the way down to -infinity. Pro tip, if you ever have infinity, you have to use parentheses because we can't say things are technically equal to parentheses, or equal to infinity, so you need to have open. Always have these roundy guys with infinity. You can remember this because infinity is round. Cool. And then on the other side, we start at 2, but it's not equal to 2, so we need to have parentheses with 2, and then all the way out to positive infinity. Because this has no bound, it goes on for forever. Bye. And infinity is always a roundy guy because it can't be equal to it. So there you go. There's a hidden equal signs in your brackets. Infinity means forever. Like my love is infinite. Anyway, okay. And then parentheses is up to but not including nothing. Or is split and is together. Yeah, that's it. Have a great time on your homework.